Okay, let's start math period. I want you to turn on camera and let's pray. Okay, it seems Lucis. Lucis, please pray for all of us.
Friends, let's pray. Thank you, God, for giving us of us so that we can do math well and so that we can focus on this new agreement.
Amen. Okay, so yeah, today we don't have quizzes, and we will have a mini quiz. The first one in this week will be on Wednesday. Okay, so please be prepared for Wednesday. We will have the mini quiz, and then for today we will speak about one additional lesson, and tomorrow, tomorrow you will have to watch a video. So on Wednesday we can discuss. Thursday we will have a review, and Friday we will have a quiz. Okay, I hope that explains. And then for now, since actually only this class that I haven't finished the Friday's material, so let's continue first with the Friday's material. I hope some of you are still have the notes from the previous one, since we will go further to discuss about x-intercepts. Okay, so the last two one. Okay, let me just annotate. Okay, let me just help you. So actually the number four, for number four, the x1 or the first x-intercept will be -2 plus square root of 60 over 4. Okay, now let me ask you then, Nicholas, how can you simplify square root 60?
Um, 2 square root of 15.
Okay, good. So it is -2 plus 2 square root of 15 plus 4, right? So in the end, it will be -1 plus square root of 15 over 2. I think it's right. I hope that this is right. Yeah, if I'm not. Okay, so again, the x2, the difference only the operation between, right? So it's in between. The first one is addition. The second one is subtraction. So this will be the next one. Okay, so for number 4, okay, okay, this is number 4, and I want you to wait. Sorry, I have to scroll this out. Okay, how about number 3? Can anyone, if you have the notes from the Fridays, you can just tell me, or you can count it quick. For number 3, the y equals x squared minus 7x minus 18. What is the x-intercept, the first one, and what is the second one? Anyone?
9 and -2.
Okay, thank you, Kimi and Felicia. 9 and -2. Okay, so let me just scroll it again. So the thing that I want you to finish about Friday's material is this. For number 3 and number 4, I want you to do the same sum x1 and x2, and then multiply x1 and x2. So for number 3, find this and this. And then for number 4, find this and this also. Please do it now, okay? I have already given you the x1 and x2. So your task is just, yeah, it's just add them. But make sure that you can do the arithmetic correctly. That's the thing. I think I can, yeah, let's just wait. Let me begin with number 3 first, since number 3 is very easy, right? Hopefully. So number 3, x1 times x2, x1 plus x2 equals. Number 4, x1 plus x2. Let me just reverse it. Okay. Number 3, Joy. x1 times x2.
Mister, so x1 is 3 and x2 is 4.
No, number 3, I mean this one. I have
Ah.
already had this one and this one. Okay, just multiply it. So what is the product?
Oh, minus 18.
Okay,
Negative.
and the sum?
Negative 11.
Sorry, this is positive 9. Positive 9 plus negative 2. It's okay, you can. 9 plus
7.
negative, yeah, 7. Okay. So next one, x1 plus x. Okay, who has already had the product and the sum for number 4?
Me.
Okay, please, Ellen.
For the sum, it's negative 1. And the multiplication, it's kind of hard. Hold on.
Okay, it's okay. You have done your job for the sum. Who has already done the product?
3.5.
Excuse me?
Negative 3.5.
Negative 3.5, so it is negative 7 over 2.
3.5.
Okay. Okay, any other different answer?
May I try for the multiplication? I just found it.
Yeah.
It's supposed to be 16, is it?
Oh no.
I mean negative 16. For the number 4.
The product? Let me
Yeah, the
just-
product.
Negative 16. Okay, we have competitor here. Okay, no, alternative. I mean, okay, now is there any other different answers?
Negative 7 for number,
Oh,
yeah, that one,
wait.
the multiplication.
Negative 7. Okay. Any other?
Mister, may I change my answer?
Yeah, Aaron.
It's actually negative 4.
Negative 4. Okay. Okay. Any other? Okay, for number 3, I think there is no objection. Okay, this is as simple as you. Okay, but for number 4, it's kind of trickier. Okay, let me just, okay, since number 3, there's no question for number 3, right? Let me just erase it. Number 3. As for number 4, let me just show you how do you add this. Okay, if you add x1 plus x2 carefully, It means I add the first one, this one. This is the x1 plus -1 minus square root of 15 over 2, right? If you want to add fraction, whenever we have this the same denominator, you can just combine them, right? -1 plus square root of 15 minus 1 minus square root of 15 over 2. So in the end, plus square root of 15 minus square root of 15, gone. So it becomes -2 over 2. It is -1. So it is correct, your answer, -1. No problem. Any question about addition? Okay, let me just erase this one. If you have no questions regarding the addition or the sum. How about multiplication? Kind of trickier, but almost like the same actually. So when I multiply, let me begin with from this. When I multiply, so it begins with -1 plus square root of 15 over 2 multiplied by -1 minus square root of 15 over 2. Multiplication, it means -1 minus square root of 15 over 4, right? You multiply both the denominator, you multiply both the numerator. Okay, so for the numerator part, of course, some of you like to use the box thing, right? If you want to use the box things, that's fine. Okay, you can use the box thing. So it is -1, and then this one is square root of 15, and this one is -1, and the other part is negative square root of 15. -1 times -1 is 1. -1 times square root of 15, negative square root of 15. Negative square root of 15 times -1, positive square root of 15. And then negative square root of 15 times square root of 15 is -15. So when you add all of it, it becomes 1 minus 15 equals -14. So it is equals -14 over 4, 2. Okay, thank you for the other alternatives, but the correct one is -7 over 2. That's how you multiply it. Any question? Really, if you have
Yes, sir.
questions, yeah.
Will we have this kind of problems in our math quiz or test? Like, so
No,
we don't have the calculator, right, sir?
no, you cannot use calculator. You have to practice this one. Okay,
Oh,
okay. Since, yeah, especially for second semester, you will play with radicals more. So let's just say that this is just the warm up. Okay. Okay. So you have to be, yeah, of course, the skills here, you have to do it, right? So you have to master. This is very, actually, it's just the multiplication of two polynomials. So any two binomials. Any question? And of course, you have to be ready to present this kind of proof. Okay, since of course I need you maybe to prove some things, and yeah. So therefore, if you have any questions regarding the steps, ask now. Any
Mister,
question?
does the
Yeah.
product and the sum of the x1 and x2 like show something, or it's just kayak x1 plus x2 and that's it?
Let me I just want to show something actually. I haven't go to the conclusion. So this is the thing that I want to teach you. But again, you need to master how to prove it. So x1 times x2 will be equal to C over A. X1 plus x2 will be equals to -b over A. Look at number 3. The C is -18. The A is 1. -18 over 1 Therefore, x1 times x2 equals negative 18. We have proven it. Okay. And the product or the sum will be negative b over a. The b is negative 7. The a is 1. Therefore, x1 plus x2 equals 7, which is the same that we have done it manually. Any questions so far?
What will we use this for?
Yeah, that's after this. Okay. And then number four. Number four, in the end, of course, you can have the shortcut here, right? The shortcut about this and about this from this formula. It means if I use the ABC, x1 times x2 will be equals to negative 7 over 2. The C over the A, x1 plus x2 will be equals to negative of B over A, 2 over 2, negative 1. Is the same. So what does it work for? It will be used for transformation on 11th grade, but you need to know now, since we are dealing with quadratic, I just want to introduce you the relation of the roots. When you multiply the roots, it will be equal to C over A. So you can directly see it from the equation. When you sum it, you can directly see it from the equation, which is negative B over A. For now, just keep it.
Mr.
Yeah.
What if the equation only have one x-intercept?
Good. So if you only have one x-intercept, let me ask you, for example, clear. This is one of the, let's just pretend we don't know it's only one x-intercept. Okay, x squared plus 4x plus 4. Actually, this is equals to x plus 2 squared. It means you only have one x-intercept. Okay, let's just pretend we are using this one. Okay, negative b over a is negative 4. You know that the x1 equals negative 2. The x2 equals negative 2. See how that applicates. So actually, you just substitute for the x1 negative 2 and x2 also negative 2. Yeah. So let's just do it as it's, although it's the same x-intercept, but by definition, because we want to sum it, so it's just we sum the same value. I hope that explains your question.
So
But
it's
of
still
course,
so
yeah.
this formula still applies, right, Mr.?
Yeah, still applies. We're consistent, but thank you. Actually, this is let's just say that since we are dealing with quadratic function, I want to explain everything, every properties, every rules that we are dealing with quadratic functions. But again, a good question from Aaron before. For now, will we use it? As long as I'm concerned, for quadratic functions real world problem, we won't have any situation that you are asked what is the product, what is the sum of the roots. Of course not. It will be used for transformation later on 11th grade, but you need to know now what is the product and the sum using the formula. Again, using the formula is not classical. Yes, therefore you need to know where it comes from, right? So let's just, that's why you have already proven it, okay? Any question regarding the Friday's material? So we have already ended Friday's material. Let me just clarify that Friday's material only this when you have the roots of quadratic function. derivation, it will be C over A. And when you add, it will be negative B over A. Okay. The derivation of the long one, you can see it on the YouTube. I don't want to explain it now, and hopefully Mr. Budi can explain further about this, since transformation is the one who will use this. Okay. Yeah. Any questions about these two rules, two new rules? Very good. Okay. So now let me go to the next one, number 5. Okay, number 5. Do you remember what is the result of number 5? What is the x-intercept? Anyone?
0.
0. Matthew, what do you mean by 0? No x-intercept, you mean, right? Not the x-intercept equals 0. Can you clarify that, Matthew?
Yeah, the x-intercept. It's a negative number. It's negative.
So there is.
It's an imaginary number.
Good. Okay, good. So previously, you say that there is no x-intercept, right? Why? Because the discriminant equals, I think it is negative 20, I think. Okay, negative 20 less than 0, it means you have two values of imaginary numbers. Okay.
Mister, I think it's negative 120.
So from today, starting. Yes, okay.
Discriminant. I think the discriminant is, wait, am I wrong? I got negative 120. Did I miscount?
Wait, let me just calculate that. Because I'm just trying to memorize that. So 100 minus 4 times 3 times 10. So it is equals 100 minus 120, negative 20.
Oh, I'm wrong there.
20.
Thank you,
Okay.
Mister.
Yeah, it's okay. As long as you can have the confirmation. Good. So now, since it is negative 20, of course, previously you just say there is no x-intercept, that's correct. On the graph, there is no x-intercept. It's not visually seen. But since now, from now, you need to find the values exactly in imaginary numbers. Why? Because actually it exists. They exist. The x-intercept is they exist. Visually, it's hard for me to graph it. That's why I share you the YouTube link today. So for you, I hope all of you are curious about this, why we should find the value of imaginary numbers while visually it's not there. Actually, it's there, but it is in another dimension. But please look into the video to explain it further about this. So for now, I will just show you how to find the exact value. The exact value is just simple, right? It's just by using the quadratic formula, of course. It is minus b plus minus square root of d over 2a, right? So in the end, x1 and x2, x1 will be equals to negative 10 is 10 plus square root of negative 20 over 6. X2 will be 10 minus square root of negative 20 over 6. So that's the exact value. They are imaginary numbers and they exist, but not visually seen on the Cartesian axis. My question is, okay. Okay, so you're welcome. Now, let me show you how to simplify this. Okay, let me ask you then, Rafa, what is the, if I try to use the factor 3, okay, How do you use the factor tree to find all of the most factors, all of the least factors? Yeah,
My mic on.
yeah, you are now.
Is it like ya divide jadi kayak 10 and 2 bisa nggak sih?
How? Yeah, just tell me the numbers.
10 and 2.
20,
10 and 2.
9, apa? Sorry, 10 and 2, good, and then
5 and 2.
the 10. Okay, so now if I have square root of 20, can you simplify square root of 20?
No, it's not apa? It's not like jadi it's like 2 square root of 5, right?
Yeah, good. 2 square root of 5. Good. Okay, square root of 20 equals 2 square root of 5. But now we have square root of negative 20. So here's the first thing that I want to teach you. Some of you may already be familiar with this. The box here, square root of negative 1 equals to I, is equal to I. Lowercase I. Therefore, from now on, you need to simplify this, any imaginary numbers, into a numbers that has I in it. Okay, let me just start from x1. Okay, since I have already known that this is from the quadratic formula, the last thing that you need to know or to do is simplify that. So square root of 10 equals 10 plus square root of 20 equals to 2 times 2 times 5 times negative 1 over 6. So it is equals 10 plus 2 square root of 5 square root of negative 1 over 6. Any questions up until now? Just make sure that you understand this since we are dealing with this a lot later. And then in the end,
So basically, what you're trying to say is that if we have like the one in blue, we have to convert it to the one in black.
yeah.
Okay.
And
And,
this is
the I thingy and the I thingy. Oh, I see. So I specifically stand for square root of negative 1 and nothing else.
Yeah.
Okay.
Mister, why can't it be written as 20i?
20 I
Like the square root of negative.
no
20.
we have no simplified. It means all of the answer must be the simplest form. The simplest form in category of real number, whenever you can simplify a radicals, you need to make it simpler. For example, square root of 20. When you simplify it, it becomes 2 square root of 5. In the perspective of imaginary numbers, whenever you have square root of negative 1, you have to simplify it into I. So actually, you have to satisfy all of the requirements as a simplest answer, simplest form. Is that answering your question? Okay.
Mister.
Okay, so in the end, this is still not the final answer, right? The final answer will be 5 plus square root of 5i over 3. Done. This is x1. And this is the thing that you have to practice how to find it. And then since I know that the x1 equals that, it means x2, you just change the operation in the middle, right? The x2 will be 5 minus square root of 5i over 3. This is addition. And this one is subtraction. That's all. X1 and X2. Any question?
Mister,
Yeah.
can
Yeah,
it
yeah.
be I square root of 5, or should it be like square root of 5 I?
Thank you. Actually, we prefer to use I at the back, just like variables. But if you want to do that, it's okay. Because there's something that I want you to be careful. You cannot write this way, minus square root of 5 and I is here. No, this will be wrong. The I must be outside the radicals, the radical sign. So the radical must stop at that point and I will be outside of it. So yes, if you use I first, sometimes it is safer, right? Because we use, let me just, I square root of 5. Yeah. But usually we put I at the back. But to answer your question, Flavia, you can. You can put it at the front. Any question? If there's no questions, let's practice then. Let me see this. Okay. Annotate, clear. Yeah. Okay, be prepared for another questions, which is this one. Now you just do it quickly. Simplify this, all of these 4 imaginary numbers. I want you to practice to simplify it. Okay, let me ask first. Farrell, number 1.
Is it square root of 3 times square root of -1?
Okay. So how do you place the I there?
Square root of 3i and then I.
Good. Good. Okay, that's how you do it. Good. Now, number 2. Okay.
So it's 3 square root of 1i.
3.
3i. Wait. 3i. Yeah, I think so.
Yeah, 3i. Good. Since it is 3 times square root of -1, right? So yeah, it's 3i. Okay, see the difference? Okay. Okay, next. This is number 3.
I don't know, mister.
Try it. At least give me any answer. It's not that hard.
I don't know, but I think it's 7.8 I.
We cannot use calculator here.
I don't know.
Okay. Okay, yeah.
For number 3, it's square root of -1 and then square root of 61. So it becomes square root of 61i.
Okay. Good. Number 4. Okay, number 4. This one is trickier. So who has already had the answer? Please unmute yourself.
Can I?
6
Yeah.
square root of 2i.
Quick, 6 square root of 2i. Good. So actually, negative 72 is 2 times 2 times 2 times 3 times 3 times negative 1, right? So actually it becomes 2 times 3 times square root of 2 times square root of negative 1. So it is 6 square root of 2 and I. Good. Any question? And if you don't have any idea, just ask. Okay. Rather than yeah.
Sir, can you please repeat, because before I was lagging, so I don't know anything about this.
I will share the video then. If you need to repeat, it means yeah, I need to share it. Okay. So the entire thing or just specific things? Which one?
The I part, the before the assignment before is all clear, but after you explain this, it's all like the I.
Okay. Okay, so now let me just conclude. Let me just conclude that the first thing that you have only learned is whenever you have roots, it is over A. Let me conclude for today's material. Okay, this is a different one, right? For number 2, imaginary numbers. Imaginary numbers. The first thing is square root of negative 1. It is equals I. And therefore, I equals square root of negative 1, of course. Okay, reflexive axiom. But the thing is that I want you to know, let me ask you then, Daud, what is I square? If I equals square root of negative 1, I square equals?
Negative 1.
Good. Now this is the thing that you have to try to understand. Okay, these two things is very important. Square root of negative 1 equals y, or vice versa. I square equals to, it's equal to negative 1. Okay.
So from now on, we need to address imaginary numbers as like I in terms of I instead of just no solution.
Yeah, that's right. From now on. Okay. So here's the thing. Just to give you a short glimpse about what you're doing on your homework, for those who really do the homework, of course. Okay. Now, I want you to practice. I give you only 3 numbers like this one, but it's kind of interesting and you have to practice it. Why? When you find that the x1 equals 5, I think I have to memorize that before we have, I think this is, yeah, it's just, please correct me if I'm wrong. So when we found the number 5 is this one. So for the 3 numbers of your homework, you need first to find the x1 and x2. If they are real numbers, just stop at real numbers. If they are imaginary numbers, you need to simplify it until this form. Okay. The next thing is you need to check. You need to check one of the solution into the equation. Will it satisfy it? Okay. So the thing is, since this is 0 equals 3x squared, we are finding the x-intercept, right? Minus 10x plus 10. So what you're doing on your homework, you can pick x1 or x2. For me, I like positive, so I will use the first one. So check whether is 5 plus square root of 5i over 3 squared minus 10, 5 plus square root of 5i over 3 plus 10 will satisfy 0. Okay, let me show you quickly. If I want to prove this, 3, this one will be 25 plus 10. Sorry, square root of 5i, okay, plus 5i square over 9, right? And then minus 10, and I will just write it the same. Sorry. Okay, and then when don't forget I square equals to -1. It means I can replace this one. Okay, so when I try to combine everything, 0 equals to 7. Wait. 3 times 25 plus 10 square root of 5i. Wait, there is no 3. 3, okay. And then minus 5. Sorry, let's cancel this one to make it simpler, right? So let's cancel the 3 there. So there is no coefficient over 3 minus, sorry, let me just go directly. I hope that you understand this one. Minus 10 square root of 5i plus 30, because I want to do it quickly, okay? So in the end, 25, this is minus, this one will be gone. 25 minus 5 is 20. 20 minus 50 is negative 30. Negative 30 plus 30 will be 0. So in the end, the statement will be 0 equals 0 over 3. 0 equals 0. Or maybe some of you are asking, Mr. kan udah jelas ini pasti terbukti. The thing is, the one that you have to practice is this one. When you square this thing and when you substitute this thing, this will be assessed. This skill will be assessed. Okay, so the point is, you know, the final answer will be 0, and that helps you to guide you if you do it incorrectly. So let's just see it as a beneficial thing. I mean, do not see it as it's just a useless thing. No, about the skill in the squaring thing that it will be assessed. I hope you understand why you should check it. Of course, you will have faith that it will be the same. But again, you need to find, or you have to master the skill of squaring it. Okay, Faustina, Alzena, Ariel.
Huh?
Yeah. So any question?
We only need to check only for the imaginary numbers, right, Mister? For checking only the one with imaginary numbers, right?
No. No.
Problems.
With the let's just read the instruction. The first 3 you have to do 2 things: find the x-intercepts and then check. So it doesn't matter if it is not imaginary, just check. Since we are using radicals, okay, I just want you to practice of squaring radicals also. Okay. And again, I have already opened a homework for tomorrow, actually. So I combine with today. So the thing is, the objective, or you have to focus on today's only. But if you want to do it earlier for tomorrow, you can do it. That's why I opened both today. Okay. Tomorrow materials, although you can see it, watch it on video, actually it's a very simple one. So I believe some of you have already understood it. But if you don't, just use the video as your assistance to find it. Okay, to understand it. So if there is no question, you may be dismissed. Oh yes, and tomorrow be prepared. Some of you I will interview one by one. Just see if you have invitation. Okay, there is something that I want to check from some of you. Okay, you can be dismissed.
Thank you, Mr.
Thank you.
Thank you, Mr.
Okay,
Mr.
welcome.
Mr.
Yes.
Where can I see the invitation if I got it?
Email. I will email it.
Oh, okay. Did I get invitation?
Just wait.
Okay. Also, Mr. For the minus B per 20 per 2A, that's Sumbu symmetry, isn't it?
Yeah.
But it's different, right, from symmetry point?
It's different.
Yeah, because I thought it was the same. Tapi pas saya hitung ternyata beda. Ternyata bukan. And I was like, tanda tanya.
Oh, you have to know the difference. I mean, the symmetric point is not the line of symmetric line. Line of symmetry is like the mirror, and the symmetric point is the shadow. It's entirely different.
Yeah, I just realized it yesterday, Mr.
Oh, okay. Okay.
Thank
Any
you so much,
question regarding
Mr.
that? Okay, you're welcome.
Bye bye. Have a nice day.
Bye. You too.